Question 5. Popular wisdom is that eating pre-sweetened cereal tends to increase the number of dental cavities in children. A sample of children was, with parental consent, entered into a study and followed for several years. Each child was classified as a sweetened cereal lover or an unsweetened cereal lover. At the end of the study, the amount of tooth damage was measured. Here are the summary data. So we have two samples. We have sweetened and unsweetened, and we're both given a mean and standard deviation and a sample size for each sample. Assuming the necessary conditions for inference are met, which of the following is an approximate 95% confidence interval for the difference in the mean tooth damage? So not the mean difference, the difference in the two means. So we see these subtractions here. That's your point estimate, the difference. And we have our critical value. Remember, our critical value, this is means. So our critical value is going to be T star. So we're looking for a T star for that number out there. So one thing I'm going to look for is if it's 95%, and for Z, we know 95% is 1.96, we know it's not going to be that. That would be if it was a Z, but this is not. This is T because it's not a proportion. So now let's go down here. Both of these all these have a 10 and 15. That's your sample size. But what's going on with the numerator? We need to be reminded of our formula sheet. I always say, let's look at our formula sheet, see if we can find anything that might help us out. And if you look at parameters for sampling distribution, you'll see for the difference for the standard error, you'll notice it's the sample standard deviations for each one squared over the respective sample size. So it's not S over N, it's S squared over N. Let's look at our standard deviations. They're both 5 and 15. So it's not going to be 5 and 15 without doing anything. It's going to be 5 squared. 5 squared and 15 squared. Well, that's going to give you 25 and 225. So we know it's going to be one of these two down here. So it's really a matter of what is going to be your critical value. And again, we're going to use either our table or our calculator. However, we have to be mindful of something. Our sample size, we have two different sample sizes. So your degree of freedom is always going to be n-1 still, but it's based off of the lowest number. And since 10 is my lowest number, we want to be conservative in our estimates. So we're always going to take that smaller number and subtract 1. So your degree of freedom is actually going to be 9. 10 minus 1 is 9. So you can use your calculator or your table. Let's use our calculator. We're going to use inverse T. And let's put that in. So inverse T is going to be second vars 4. And we'll leave it at 1 plus 0.95 divided by 2 for my last question. But I'm going to make that 9 my lowest degree of freedom. And there's your degree of freedom, 2.262. So we know it's going to be that answer choice B, 2.262. So again, you can use table B or you can use the calculator and make sure you use the conservative estimate.